So in Algebra 1, you might have learned about parabolas. They have this U shape, and you probably have graphed some functions that have this shape. However, what is the definition of a parabola? And a parabola is just a set of all points that have the same distance from a point called the focus and a line called the directrix. So in this case, I have this graph here. This is a parabola. And what you notice is that if, let's say, I take the vertex of my graph, vertex of my function, you'll notice how the distance from this vertex to this focus, right, this singular point, is 2, right? This distance is 2. And you notice how the distance from this vertex to this line is also 2. You notice how the distance from, let's say, this point to the focus is 4. And you notice how the distance from this point to the directrix is also 4, right? 1, 2, 3, 4. So the parabola is just a set of all points. If I pick any point here, the distance away from whatever that point is to this focus is going to be the same distance as whatever point I choose to this line I've drawn. Now here's something pretty cool. So we have this function here, parabola, and we have the directrix at the bottom, which is our line, and we have the focus up here. Notice how if I move the focus up, well, because the distance away from this point to this graph is getting bigger and bigger, well, my directrix is going to go lower and lower, right, to increase the distance away from this line to the point. Because as the point moved further away, we have to move the line further away as well to make up for the distance gained. And what you notice is that my point is always above this line. So if the parabola opens up like a U shape, well, my focus is always going to be above the line. If all of a sudden the point goes below the line, so let's say if I move this point below the line, well, if the point is below the line, then my parabola is this upside down U shape, okay? So just to recap what I did, if the point is above the line, then the parabola opens up like a U shape. If the point is below the line, then my parabola opens up in this upside down U shape. Now, how can I connect everything together algebraically? So for example, if I wanted to, let's say, write the equation for a parabola with a focus at 6, -4, and a directrix at y is equal to -7. Well, how can I solve this? And the thing you need to know is that you got to memorize this formula. Sorry if this is really long. I didn't create this. We have y is equal to 1 over 4p, where p is the distance the vertex of our parabola is from the focus. And this is going to be multiplied by x minus h squared plus k, where h comma k is our vertex of the graph. If this seems daunting to you, just know that the second part of our formula is literally the vertex formula for a parabola. So, then all you got to memorize is 1 over 4p, which is pretty simple to memorize. Now, before going into the hard problems, let me just show you an example problem. So if I have my focus at 3, 1, and I have the vertex of my parabola at 3, -1, with a directrix at y is equal to -3, what is the equation of my parabola using this new equation I've shown you? Well, let's try to find out what each variable is in this case. So first of all, what is p? We know p is the distance the vertex of my parabola is from the focus. So what's the distance from my vertex, which is 3, -1, to my focus, which is 3, 1? And obviously, you'll notice how the distance from this focus to my vertex is 2, right? This distance right over here is 2. Right, you go from -1 to +1, so the distance is 2. So p is equal to 2. And what's the coordinates of my vertex? Well, the coordinate of my vertex is 3, -1, which means that h is equal to 3, right? H is equal to 3. And the y value of my vertex, k, is equal to -1. K is equal to -1. And now all we have to do is just plug this into our formula. So the formula for my parabola is just going to be y is equal to 1 over 4 times p. 4 times. We know p is equal to 2, so let's just plug it in here. And 4 times 2 is just 8, so we can write this as 1 over 8 times x minus h, x minus 3, right? H is equal to 3, squared, plus k. And we know that k is equal to -1, so plus -1 or -1. And that is the formula for our parabola. So you notice how it seems very complicated at first, but at like the end of the day, like there's only 3 variables you kind of have to memorize. So yeah, it's not that bad. Let's do another example. So let's say that our focus is at the coordinate 0, -4. Sorry if this is a little hard to see. And let's say the vertex of our graph is at 0, -3, with our directrix at y is equal to -2. Find the equation of this parabola using this information. Well, we know that the distance from our vertex to this focus, right? If this focus has a y value of -3, and this focus has a y value of -4, well, the distance away from each other is just 1. So p is equal to 1, right? Because p represents the distance between the focus and the vertex, and we know that the vertex of our parabola is 0, -3, meaning that h is equal to 0, and k is equal to -3, right? Because k represents the y value of our vertex, which is -3. Now all we have to do is just plug it into our formula. So y is equal to 1 over 4 times p, which is 1. 4 times 1 is just 4, so we don't need that. Times x minus, we know h is 0, so just x minus 0 is just x. And then plus k, which is -3. So k, we know that's -3, so x squared minus 3. Now this is where a lot of people get this wrong. A lot of people forget to put a negative sign at the front. And the reason why you need a negative sign at the front is because our parabola is facing upside down, right? If our parabola was facing up, we don't need a negative sign, right? If this was like y is equal to x squared, you notice how it's y equals to positive x squared. However, if the parabola is facing downwards, well, let's say this graph is y is equal to -x squared. You notice how there's always a negative sign when the parabola is facing downwards, and there's always a positive sign when the parabola is facing upwards. Meaning that since our parabola in this example was facing downwards, we needed a negative sign in front of the 1/4, right? So this is our brand new equation for our parabola. It's -1/4, right? This negative sign is very important because it shows that our thing is facing downwards because our focus is below the directrix. -1/4 times x squared minus 3. And you notice how if we actually graph this, well, our parabola is facing downwards with a vertex of 0, -3. If we did not include this negative sign in front of the 1/4, notice how now the parabola is facing upwards, which is not what we want, because the focus is below the directrix. Write the equation for parabola with a focus at this point and a directrix at y is equal to -7. So this problem is tricky because they don't tell us where the vertex is, right? They only tell us where the focus and directrix is. So how do we approach this? It's always good to visualize what's happening. So we have a focus at 6, -4, which is 6, -4. Let's just say it's here. 6, -4. And our directrix is at y is equal to -7. So let's just say that this is... Now, one thing you notice is that my focus is above the directrix. And it's exactly what I'm showing here. Remember, if the focus is above the directrix, that means your graph is going to be opening upwards. It's going to be a smiley face, right? So that means my graph is going to look something like this. I'm just going to draw it like this. Another thing you notice is that my focus and my vertex always have the same x value, no matter where I go, right? Even if even if the parabola is facing downwards. My focus and my vertex always have the same x value. It's only the y value that's different. So if I go back, if I know the x value of where my focus is, which is 6, that means that my vertex also has to have x value of 6, right? And now the only thing we have to deal with is what our y value is. So to find the y value, what you do is you take the line, or you take the number from the equation of the line, so -7, and you take the y value of the focus, which is -4, and you take the average of those two numbers. So if you take the average of -7 and -4, you get -11/2. And that's going to be the y value for our vertex, -11/2. Now, why does this work? Well, the reason why it works to take the average of the y value right over here of the focus and the y value, just the y value of the line, which is -7, is because that we know a parabola. Once again, I'm just going to repeat the definition. The parabola is the set of all points that's equidistant from the focus and the directrix. And if the vertex right over here has the same x value as the focus, well, that means that it has to be the y value has to kind of be the average, has to be in the middle of -4 and -7, right? The y value has to be in between -4 and -7, because if the x value of my focus and my vertex is the same, well, the distance from this vertex, this focus, has to be the same as the distance from the vertex to the directrix. And you basically have to find a number that's in between -4 and -7. And that's where you take the average of those two numbers and you get -5.5, which is in between, or -11/2, which is in between -4 and -7. They're equidistant, right? So now that we have found the vertex, the rest of the problem is pretty straightforward. What you do is you want to find out what P is. P is the distance from the vertex, the distance the vertex is from the focus. So if this is -5.5, right? If the vertex has a y value of -5.5 and my focus has a y value of -4, well, this distance right over here has to be 1.5, right? 1.5. So that P is equal to 1.5. The x value of my vertex, aka h, is 6. H is equal to 6. And my y value of my vertex, aka k, is -11/2. So now we just have to plug everything back into this formula, and we get 1 over y is equal to 1 over 4 times p, which is 1.5. 4 times 1.5 is just 6, times x minus h squared. So we have x minus 6 squared. And then plus k, or plus -11/2. And there's our answer. And if you plug this into Khan Academy, it'll show you that it works. Write the equation for a parabola with a focus at -8, -1, and a directrix at y is equal to -4. So, how can we solve this one using the strategy we did for the last problem? Well, first of all, we want to just visualize everything. So the focus is -8, -1. So let's just say it's right over here. That's our focus, -8, -1. And our directrix is y is equal to -4. So this is y is equal to -4. Now, because our focus is above our directrix, we know that the graph is going to look something like this, right? It's going to be a smiley face, right? Because our focus is above the directrix, our graph is going to be facing, our parabola is going to be facing upwards. Now, we also know that the x value of our vertex is going to be the same x value as our focus. meaning that if our focus has the coordinates -8, -1, well, our parabola, the vertex of our parabola is also going to have the x-coordinate of -8. And now to find the y value, remember what you do? You take the average between the y value of the focus and the y value of just the equation of the line. So the average of -1 and -4 is -5/2, right? This is going to be the thing in the middle. -5/2. It's going to be our y value. And now all we have to do is just plug this back into our equation. But first we have, before we do that, we have to find what p is equal to. I don't know why I wrote a there. Alright, so first we have to find out what p is equal to, which is the distance from the vertex of our parabola to the focus. If our focus has the y coordinate of -1 and our vertex of the parabola has the y coordinate of -5/2 or -2.5, well, this distance right over here is just going to be 1.5, right? This distance right over here is just going to be 1.5, meaning that p is equal to 1.5. We know that h, aka the x value of our vertex, is -8, right? So h is equal to -8, and k is equal to -5/2, right? That's the y value of our vertex. So now we could just plug everything in. So 1/4 times 1.5, which is just 1/6. This is going to be y is equal to 1/6 times x minus -8. Right? If we plug in -8 for h, it's going to be x minus -8, which is just x plus 8 squared. And then plus k, we know that k is -5/2, so plus -5/2. And there is our answer. Just a quick note that this formula also works for the types of problems that I showed you before, except this time you don't even have to find the vertex of the graph. The only problem with this formula is it's very long and it's way trickier to memorize, but it still works. So whatever formula you use, it's up to you. You can also have parabolas that are horizontally shaped. So in this case, we have the graph of x is equal to y squared. And the reason why this works, why this kind of looks like this, is because you have x equals y squared. If you want to solve for y, you can take the square root of both sides. So this cancels out, and you get y is equal to plus or minus x, the square root of x. So you notice if you graph both of these things, so if you graph y is equal to the square root of x, and you have y is equal to the negative square root of x, because it's plus or minus, right? And you notice how these two graphs, when they come together, they form this horizontal parabola, just like what we had originally. Now, an important thing to know is that if there's a positive number, so if the number in front of the y squared is positive, it's going to open up to the positive side, right? You notice how this thing opens up to the positive side? And if there's a negative number in front of the y squared, let's say if we did -1, well, you notice how it opens up to the negative side. All right. So once again, this is another formula you gotta memorize. Very similar to the first formula that we did, but this time it's x equals 1/4p times y minus k. So not h anymore. So y minus k squared plus h, where h comma k is the vertex of your graph, and p once again is just the distance the vertex is from the focus. So one example of how you would apply this formula is, let's say if we have a focus at 7, 3, we have our vertex at 4, 3, Directix at x equals 1, and we want to find out the equation of this parabola. So if p represents the distance the vertex is from the focus, so if this point right over here is 4, 3, and this point right over here is 7, 3, the distance is just going to be 3 units, right? So p is going to be equal to 3, And we know the vertex, we know that the x-coordinate of our vertex is 4, which is h, and the y-coordinate of our vertex is 3. Now just plug it into the formula. X equals 1 over 4 times p, so 4 times 3, we know 4 times 3 is 12, times y minus k, so y minus, we know k is 3, so y minus 3 squared, and plus h is 4, so that is our equation. And yeah, this looks about right. Our vertex is 4, 3, and it's opening outwards to the positive direction. Write the equation for a parabola with a focus at 0, 5, and a directrix at x is equal to -7. So for these types of problems where you're kind of solving for the equation of the parabola in terms of x, the strategy is very similar to what we did. So the first step you always got to do is you got to visualize what's happening. So you have a focus at 0, 5, so 0, 5, and you have a directrix at x is equal to -7. Now, one thing you notice is that if my focus is to the right of the directrix, so when I'm talking about sideways parabolas, and if my focus is to the right of my directrix, that means that my parabola is going to be facing outwards in the positive direction. If my focus is to the left of my directrix, the parabola is going to be facing the other way, facing to the negative side. So this means that you'll notice how my directrix, in this case, is behind my focus, which means my parabola will have a shape like this. Will be facing to the x, will be facing to the positive direction. And another thing you notice, if we go back to the graph, is that the vertex of my parabola, keep an eye on the gray dot. So you notice how if I move my focus up and down, you notice how the vertex of my parabola and my focus have the same y value. It's just that the x values are different, which means that if the coordinates of my focus is 0, 5, that means that my vertex is going to have a y value of 5. The y value of my vertex is always going to be the same as the y value of my focus. And now, to solve for what the x value of what my vertex is, what you do is you take the average between the x value of the focus and the x value of the line. So you take the average between this x value and this x value right over here of the focus. This is the average, right? You divide it by 2. And that kind of makes sense because our vertex point is in between those two values. So in order to get like the point that's equidistant from the directrix and the focus, well, you just have to take the average between the two things and you get -7/2, which is going to be our x value. -7/2 is also the same thing as -3.5. And you notice how the distance between my vertex and my focus is 3.5, right? This thing has the x value of -3.5, and my focus has an x value of 0. So the distance between my vertex and the focus is going to be just 3.5 because it has the same y value. So that means that p, which is the distance between vertex and parabola vertex, is going to be 3.5. The x value of my vertex is -7/2, and then the y value is going to be 5. So the equation of the parabola is going to be x is equal to 1 over 4 times p. So 1 over 4 times 3.5. 4 times 3.5 is 14, times y minus k squared. So y minus 5 squared, plus h, which is -7/2. And there's our answer.